Okay, so from our theory equation, we know this is going to be my equation, right? And this part is going to be my theory gradient. So, and I just go theory gradient equal to square root 16 pi squared e cubic divided by k. Okay, and then this is the answer Rachel gave me. So this is her measurement, and it's really good because you need to have uncertainty, which is the smallest interval of the instrument you use, which is 1 millimeter, right? So you got one uncertainty, you got two uncertainty, now you need to process it. To make it easier, I mean, I know this is going to be 4 pi, right? So I can just put the 4 pi to the outside, and I just need to calculate this thing over here. D cubic, k, and square root. Okay? So how do I do that? I go like this. 4 pi, I put the thing inside. So D is 0.278 plus minus 0.001 cubic. And then divided by k, which is 0.35 plus minus 0.01. Does that make sense? Okay, and this is a complicated calculation. How do I calculate it? And I know if there is power, if there is square, if there's divide, I need to first turn that thing into a percentage uncertainty, right? That's the first thing I need to do, okay? So let me turn that into percentage uncertainty. Okay, how do I turn into percentage uncertainty? I use small divided by big and then times 100, right? Okay, can anyone quickly do this for me?
Pretty sure it's 0.36.
Okay.
0.36.
0.35%? 3.36. Okay. Okay. And this one, okay, be careful. This one don't need to be one significant figure. So percentage uncertainty, in fact, why don't we just say we're going to give a 3 significant figure? Okay? There's no fixed rule, but or 2 significant figure, depending on things. But it doesn't need to be one SF, because if it's one SF, you're going to have two. You're going to be changing the value too much. Okay, so make sure you don't use one significant figure. Okay. So say over here, now turn this one into percentage uncertainty. How much percentage is that?
2.86.
2.86.
Yeah.
Okay, I just give it a few uncertainty, a non-significant figure, make it more accurate, right? Okay, so now what is the next step we do? The next step you do is very, very easy if you know how to do it. So it goes like this. 4 pi square root 0.278 divided by 0.35 plus minus your uncertainty.
Oh.
Okay? And then, yeah, so that's the thing. How do I figure out this uncertainty, right? So the percentage uncertainty, you're going to use a rule. Your rule is, first, this thing is going to have a cubic. If it has a cubic, what is the rule? Yeah, cubic is 0.36 multiply 3. So that is the uncertainty of this part, right? And then if it divides something, how do you process the uncertainty?
Add them together.
Yeah, it's adding them together. So now you're going to add 2.86%. Okay? And now you got the total uncertainty over here and your square root. So what do you do when you square root? The rule is you divide the uncertainty by 2. So you divide this whole thing by 2. That is actually just your uncertainty. Does that make sense? So we are using the rule is cubic times 3. So this one you need to times 3. This is divide. This is divide by this. If you divide something, divide or multiply, you add the percentage together. So you add this one together, and then the whole thing is going to be square root. You're going to divide it by 2. Okay. So and then you put this in the calculator, and you put this value in the calculator as well. So I'll write it on the back because I run out of space on the camera. So I'll write it over here. Can anyone quickly help me to put this in the calculator? Hey?
0.89.
This is here. 0.8.
891227083.
Cube which one? Oh yeah. I do need to cube that. Sorry, my bad. Yeah.
Oh.
Yeah. Good. Yeah, I need to cube this thing. Yeah, because this cube is cubing that. Yeah.
0.248.
0.248. Yeah, everyone have a try. 0.248. Okay, great. Okay, and then plus minus what percentage? 1.17. 1.97%. Okay, fantastic. So now I need to turn this percentage back into my absolute uncertainty, which use this value times this value divided by 100, right? Okay, quickly see what we can get.
0.00.
Okay. Plus minus 0.00949.
49.
Okay.
No, not 9. 49.
Oh, 0.049?
Yeah.
Okay, and let's have a look. Now, what I need to do is, this one I can only give it one significant figure, so it becomes 0.005. And this one, I need to keep it to the same decimal point, and then perfect, this is already the same decimal point. And that's it. But one more thing I need to do. What is the one last thing I need to do? I need to figure out what is the unit over here.
Oh.
Okay, so the unit, how do I figure out the unit?
Wait, don't you have to times it by 4 pi?
Didn't I times 4 pi already?
No.
No.
Oh, no, I haven't times 4 pi.
Oh, thank
Okay.
God. I was like,
Well,
oh my
if I
God.
haven't times 4 pi, then over here I need to times 4 pi. That is the value you need to times 4 pi. Now it's 4 pi times this thing, and this whole thing is uncertainty here.
Oh my god. Okay.
Okay, that's good. I was fully
Yeah,
like,
because if you times something, it's not going to change the percentage uncertainty. So uncertainty is this. This uncertainty is adding this uncertainty because they divide, right? Then you're adding this uncertainty because they multiply. What is the uncertainty of this one? That's 0. Because 4 pi does not have any uncertainty, right? So this one doesn't have 0, so that's 0. You add 0, it's still 0, so it's just that. Okay, so then what is this value then?
3.11. 3.
3.113?
oh my God, I got that.
Okay.
That one.
3.13, well, let's keep it 3.113. Okay, and then, there's an issue here. I can only use 2 significant figure because over here 0.35 is only 2 significant figure, right?
Yeah.
So I'm going to round it at the end. Okay, so 3, and then now what is the absolute uncertainty? Now we need to turn this back into absolute uncertainty.
0.0614.
Okay. So now this needs to be one significant figure, 0.06, need to be same decimal point, 3.11 plus like this.
Yeah.
Let's have a look. The original value, how much decimal point or how much significant figure do I have?
2.
The maximum I can have is actually only 2 over here, but that is 3.
Yeah.
So that can't be right. So this has to be rounded to 3.1.
Okay.
Does it make sense?
Yeah.
If that round to 3.1, what does this one need to round to? They need to be the same decimal point, so plus minus 0.1. That is your final answer.
Oh my god.
Okay. Okay. So then let's trace back over here. We haven't finished yet.
Oh my God, I got the right answer and I did not do that working like that.
Yeah. So you need to know what is the unit. The unit of this thing, this whole thing, the theory gradient equals to t divided by square root m. What is t? Second. What is square root m? Square root kg.
Oh
So
yeah.
that is going to be the unit of your theory gradient. So now we come over here. That is second per square root kg.
Okay.
Okay, so that's how we do this thing. This is quite complicated because we got such complicated equation, and also we got two uncertainty. If your exam have that, then you gotta spend all this effort to do that. If you don't have that, then
Could this
not okay.
then become an excellence?